The law of large numbers and consistency. The law of large numbers states that under general conditions, big Y bar will be near mu sub big Y with very high probability when n is large. This is sometimes called the law of averages. When a number of random variables with the same mean are averaged together, the large values tend to balance the small values, and their sample average is close to their common mean. For example, consider a simplified version of our student commuter's experiment in which she simply records whether her commute was short, less than 20 minutes, or long. Let big Y sub I equal 1 if her commute was short on the ith randomly selected day, and big Y sub I equals 0 if it was long. Because she used simple random sampling, big Y sub I through big Y sub n are independently and identically distributed. Thus, big Y sub 1 through big Y sub n are independently and identically distributed draws of a Bernoulli random variable, where from table 2.2 the probability that big Y sub I equals 1 is 0.78. Because the expectation of a Bernoulli random variable is its success probability. The expectation of big Y sub I equals mu sub big Y equals 0.78. The sample average big Y bar is the fraction of days in her sample in which her commute was short. Figure 2.8 shows the sampling distribution of big Y bar for various sample sizes n when n equals 2. Figure 2.8a, big Y bar can take on only three values, 0, 1/2, and 1. Neither commute was short. One was short, and both were short, none of which is particularly close to the true proportion in the population, 0.78. As n increases, however, figures 2.8 b through d figures 2.8b through d, big Y bar takes on more values, and the sampling distribution becomes tightly centered on mu sub big Y. The property that big Y bar is near mu sub big Y, with probability increasing to 1 as n increases, is called convergence in probability, or more concisely, consistency. See key concept 2.6. The law of large numbers states that under certain conditions, big Y bar converges in probability to mu sub big Y, or equivalently, that big Y bar is consistent for mu sub big Y. The conditions for the law of large numbers that we will use in this text are that big Y sub 1 through big Y sub n are independently and identically distributed, and that the variance of big Y sub 1 sigma sub big Y squared is finite. Pardon me, big Y sub I sigma sub big Y squared is finite.